Okay, tonight's little video is on combinations. The difference between a combination and a permutation is that in a combination, order of selection does not matter. It's only the end result or the end group that you're looking at. Some keywords to look for are groups, committees, selections, how many different ways can you choose 5 people to be on a committee, things like that. So the real difference between what we did before with permutation and what we're going to do with a combination is this. Let's say I need to choose a group of 3. So I want a group of 3 from 5 people. If it's a committee, then order of selection doesn't matter. Say I need 3 people to go down to the loading dock to pick up some boxes for me that were delivered there. It doesn't matter what order I select those 3 people in. All that really matters is that I'm going to end up with the group of 3 that I choose. So the difference is this. Again, I got those same people, A, B, C, D, and E. And I believe their names were Abigail, Bob, Claire, Dora, and Ellen. And so I'm going to choose those 3 people and say I choose A, B, and C to be the 3 people that I send to the loading dock. No, wait a minute. I don't really want that. What I want instead is C, B, and A. Well, Claire, Bob, and Abigail are saying, wait a minute, it's the same group. You didn't change anything. Just because I chose them in a different order doesn't change the actual group itself. So what you need to realize here is that when you're talking about combinations, there's repetition within each group of 3 or the permutations. If I wanted to know the total number of permutations of 5 people arranging 3, I would take the permutation of 5 things 3 at a time, which would be 5 times 4 times 3. What you need to understand, though, is that with these 3 people here that I have picked, there are actually 3 factorial ways to arrange just these 3 people, Abigail, Bob, and Claire. Just them. In how many different orders can I select those 3 people is going to be 3 factorial. So I've got Abigail, Bob, and Claire, Claire, Bob, and Abigail. I could do Abigail, Claire, and Bob. I could do Claire, Abigail, and Bob. I could start with Bob and do Abigail and Claire, or Bob and Claire and Abigail. And you can see here that I have 1, 2, 3, 4, 5, 6 different ways to just arrange those 3 people, Abigail, Bob, and Claire. So what I want to do then is divide this by my 3 factorial, which is going to be my repeats. So even though there's 60 ways to arrange 3 people, for instance, the last example I had was the seats. When I divide by the 3 factorial, which is 6, I'm actually going to get 10 actual groups, distinct and different groups, when order doesn't matter. So here's another example of a combination. You go to the video store with your aunt, and she says, oh, we're going to have a great weekend. It's going to be raining all weekend. We're going to have a movie marathon. We're going to make popcorn and just sit around and watch movies all day. So you go to the video store, and everybody scatters and comes back. I know, we don't go to video stores anymore, but let's pretend. Everybody scatters and comes back to the counter with their movie selections. And they dump them all out on the counter, and there's a love story, there's a science fiction story, there's a horror, scary story, there's a mystery, an action film, a comedy, a drama, a Disney film. And your aunt says, no, we'll take 4. We're not going to take all these movies. We don't have that much time on our hands to watch movies. So she says, let's pick 4 to take home out of the, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8 different movies that are sitting on the counter. So the question becomes, how many different combinations of 4 movies can we take home? Okay, so again, the combination of 4 movies from 8 starts out as a permutation of 8 movies 4 at a time. And that would be the selection in order of movies. And so the permutation of 8 things 4 at a time would be 8 times 7 times 6 times 5. Because you are choosing 4 movies, you have 8 choices, 7 choices, 6 choices, 5 choices. So that is going to give you the total number of arrangements, or how many orders can you pick these movies in. Then I'm going to divide out by the repetition in the groups. Because I'm taking home 4 movies, there are 4 factorial ways for me to just arrange those 4 movies. So let's say I take a comedy, a love story, a Disney movie, and an action film. Okay? It doesn't matter if the clerk checks out the comedy, then the action film, then the love story, then the Disney film, or the comedy, then the Disney film, and the action. Doesn't matter. It's all the same. So this is how many of these permutations are going to be actual repeats of the 4 groups, of the 4 in the group. So if I were to do this by hand, I would have 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. Okay, and then I could start to take out some factors here to make this a little bit easier to multiply. I end up with 35 times 2, which is 70. There are 70 different 4 movie combinations out of these 8 movies. Now here's the beautiful thing. You don't have to remember any of this, because the calculator also does combinations. It is again under the math menu. This time when you go to your probability and you look at menu item number 3, you will see the combination of n things r at a time. And in this case, you would take 8 things and you are choosing 4. When you put that in your calculator, the calculator will tell you 70. So you don't have to remember how the combination is formed by starting with the permutation and then dividing out the repeats. You don't have to remember any of that. Just know that it's a combination. Put that into your calculator and you will get 70. So this is another kind of problem. How many committees of 4 can be chosen from a group of 5 men and 4 women? And when we're doing this kind of combination, what you need to be careful of is that you're going to choose a committee of 4. If you don't care whether there's men or women on the committee, you just want any 4, then we're going to set this up as a combination of 9 people, the 5 men and the 4 women, total 9, and we are choosing 4. Okay, 9 choose 4 is going to be equal to 126. There are 126 total committees that have 4 different people. Okay, so now what I'm going to do, I have a committee of 4 again from the same group of 5 men and 4 women, but this time I want specifically 2 men and 2 women on the committee. So what you need to keep in mind here is that you're going to be choosing 2 men, but you can only choose the 2 men out of the 5 men that are in the group. And also, so I'm going to multiply, I'm going to choose 2 women out of the 4 women that are in the group. Okay, so that's important for you to understand that this is the choice for men and this is the choice for women. Again, you can only choose 2 women out of the 4 that are part of the group, and the 2 men can be chosen out of the 5 that are part of the group. As I calculate this now, and you can use your calculator or, probably the best way, 5 choose 2 is actually 10, and 4 choose 2 is actually 6. And so 10 times 6 is 60. So 60 of these 126 groups actually have 2 men and 2 women. Okay? So that's just kind of a different type of problem. Okay, so keep in mind, permutations, order matters, combination, order does not matter.